Well, hello again, class. I trust that you watched that video, the one previous to this about the trigonometric ratios, but I want to review some of that with you right now. These words and terms are completely strange to us, and try not to worry about the names, but just the idea. Trigonometry, in terms of right triangles, deals with ratios of sides to one another. You remember the 45, 45, 90 triangle. They were in a certain ratio to each other. The same with the 30, 60, 90. Now, let's draw a right triangle here. And let's call that angle X. Would you agree that the side across from angle X is called the opposite side? I hope you'll agree with that. Now, the term adjacent comes in here. All right, in terms of this little angle, this side is adjacent to it, and that side is, well, adjacent means next to. But this one's already got a name. It's across from the right angle, so this is the hypotenuse. I'm just going to abbreviate it that way. And so this is the adjacent side. Now, some students have a hard time figuring that out, but all I can suggest is pretend you're inside that little angle looking out. This is your opposite side, that's your adjacent side, that's your hypotenuse. Or let's do one that looks like this. It's not a very good one. But let's pretend this is angle Y. I hope you'll agree that that's your opposite side. This would be your adjacent side. And even though this one is adjacent to it also, it has another name. So we use that name. That's the hypotenuse. Now, let me change colors here. In terms of these ratios, we have what's called the sine of an angle. Again, don't worry about where the name came from. I don't even really know. But the sine relationship of any angle in this right triangle is always going to be the opposite side over the hypotenuse. The cosine, abbreviated COS, is always going to be the adjacent side over the hypotenuse. And the tangent relationship is always going to be the opposite over the adjacent. Now let's see, what do I want to do here? All right, what I want to do is I want to erase these two. No, I'm going to create a new page because I may want to come back to that. Let's see, how do I go to the next page? Here we go. Now there's this phrase to help students remember. It's called so, ka, toa. And what this means is that this is sine is equal to opposite over hypotenuse. Sine opposite over hypotenuse. Ka is cosine is equal to adjacent over hypotenuse. And tangent is opposite over adjacent. So if you can remember so, ka, toa, you can remember these relationships, and you do have to memorize them. So let me draw a nice red triangle here. Again, this is only applying to right triangles. And let's call this 3, 4, and 5. And we'll call this angle X. So what I want to do is, if I want to find the sine of angle X, and again, this is a relationship. Sine is opposite over hypotenuse, so opposite over hypotenuse would be 4 over 5. If I wanted to find the cosine relationship of that angle, it's going to be adjacent over hypotenuse. So that's going to be 3 over 5. And if I want to find the tangent relationship of that angle, it's going to be opposite over adjacent. Now, I hope you're copying this stuff down and thinking through it. One thing that's nice about this video, you can pause it and go back and think through that again. Now, at this point, I want to go to your practice worksheet. And again, frustratingly, I can't write on it, so I'm going to have to go back and forth from here. But let's, if I got the right thing here, let's go here. And I hope you have that Calculator 84 app. And let's see here. I forget where mine is. There it is. Because we're going to be needing this. All right, so find the value of each trigonometric ratio. And hold on just a second, guys. There were certain examples I wanted to do with you. I want to do examples 1, 2, and 3. All right, again, I wish I could write on here. But the sine of this angle, remember sine is so, opposite over hypotenuse. That's going to be opposite 28 over 35. Okay, well, let's put 28 in our calculator and divide it by 35. So we got 28 divided by 35, hit enter. All right, that's 0.8. Well, I don't see that here. So let's go to math, number 1 frac, and hit enter again. All right, 4 over 5. So the sine of angle C, opposite over hypotenuse, is answer B. Now, all the answers are on the last page of this. But I want to see your work, including coming up with the fractions and reducing them. All right, let's look now at the tangent, number 2, of angle Z. All right, that's this angle right here. Well, tangent, again, you have to memorize those trig functions. Tangent is opposite over, oops, that's not adjacent, is it? That's the hypotenuse. It's going to be opposite over adjacent, 27 over 36. And that's 0.75, which I happen to know is 3/4. You may know that too, but let's pretend you didn't. Go to the math button. Incidentally, you may not know where the math button is, so let me go here. The math button was right there. And hit number 1 fraction, and you get 3 over 4. So that would be answer D. Okay, I want to do number 3 with you. This is a cosine of angle Z. Well, again, you have to know what the cosine relationship is. It's adjacent over hypotenuse. So the adjacent side to this angle, that's the opposite. Oops, don't want to do that. In fact, I don't know what I did. Well, we'll see. This is the adjacent side. That's 9. That's the hypotenuse. So 9 over 15. See, what does that do? Okay, so 9 over 15, let's see, 9 divided by 15 is 0.6, go to math, frac, so that's 3 over 5. All right, so the rest of those I want you to do on your own. Now, let's go to where we actually compute sides. So let's go to number 9. Oops, there we go. Now, today I'm going to teach you about how to find the missing sides. Tomorrow it's going to be the missing angles for the next class. Now, before we begin, when you deal with trigonometry, you have to make an adjustment in the mode of your calculator. If you don't, you'll always get the wrong answer. So let's go back to our calculator screen. While we're here, I'd like to point out to you the sine, cosine, and tangent functions. We're going to use those in a minute. Also, while I'm here, look above those in the little light blue. Sine to the -1 power, cosine to the negative power, tangent to the -1 power. That's what we call the inverse sine, inverse cosine. We'll deal with that tomorrow. But to access that, we're going to go second. But for today, we're going to deal with sine, cosine, and tangent. Now here is the mode button right there. Whoops, that's pretty cool. I didn't know it would enlarge. All right, let's try it again. Oh, well, that's neat. All right, so that's the mode button. Now, go into the mode button, and you will see this word radian in black. It's highlighted in red so that you can see it. You'll see it in black. That's the default position. In trigonometry, you have to be in degree mode. Whoops. There we go. We need to be in degree mode. So what you want to do is you simply want to move your cursor over one till degree is highlighted, and then if I remember right, you have to hit enter. Then, frankly, I don't know if this thing on your calculator goes back and reverts when you turn it off or not. So when we're doing trigonometry, you're going to constantly have to go to mode and change it from radian mode to degree mode. Okay, so let's go back now here. All right, we want to find the length of this side. And we say to ourselves, okay, dealing with angle 50, I have an adjacent side and a hypotenuse. What would that be? Which trig function? Adjacent hypotenuse. And hopefully you remember that that's cosine. And I've already forgotten what it looked like. So that was 50 degrees, 10 over x, all right. We had 50 degrees there, 10 here, and x there. So to find the length of this side x, we're going to use cosine because it's adjacent over hypotenuse. So what we do is we say, all right, cosine of 50 degrees is going to be adjacent over hypotenuse. And now we're going to solve for x. And so we've divided by 10. We're going to multiply both sides by 10. And that will give us the length. So what we're going to do, let me go back to my pictures here. And I've already forgotten what it was. Okay, so it's going to be 10 times cosine 50. So in your calculator, type in the number 10. You don't have to hit the times button. You can just go right to cosine. And you'll see parentheses open up, and then type in the number 50. Now, it occurred to me I haven't checked to see what mode I'm in, so let me check right now. Yep, I would have gotten it wrong. I was in radian mode. I need to go to degree mode. All right, so going back to my screen, let's see, how do I get back there? All right, 10 times cosine 50 is 6.43, rounded off. So we'd say x is approximately 6.43. All right, let's go on to the next problem here. That was, I want to do 9, 10, 9 and 10 right here. All right, in 6.43, that was answer B, all right? So I want to find this length, its opposite and a hypotenuse. All right, so which trig function deals with opposite and hypotenuse? SOHCAHTOA, sine is opposite over hypotenuse. So let's go back to the drawing board. And good golly, my brain is not working. 8. So to find the length of that side, I'm going to do sine of 75 degrees is equal to the opposite over the hypotenuse. Now, to get x by itself, I multiply both sides by 8. And we're ready to go. So in the calculator, we're going to type in 8 and then sine 75 and hit enter. And I get 7.7 approximately. So let's go back to the example, see if that one was there. Sure enough, 7.7. Okay, now I want to show you a couple examples that are a little bit more difficult. Let's go to 21 and 22. In fact, let's jump right to 22. Now to find this length, again, you have to say to yourself, all right, what is that side compared to the angle? That's the adjacent side, this is the opposite. So which trig function does opposite and adjacent? Well, that would be tangent, right? Okay, so let's write our whoops, that's wrong. This is going to be 11 over x. And good golly, what was the angle? That's not what I want. 49, all right? Okay, so tangent is opposite over adjacent. So what we've got here is we're going to say the tangent of 49 degrees is equal to the opposite over the adjacent side. Okay, now what's weird about this, obviously, is that the x is in the denominator. I need it up in the numerator. So to take care of that, I'm going to multiply both sides by x. So on the left side, I have x times tangent 49 equals the number 11. Now that may not be completely obvious to you that this is x times that, but it is. And so to get rid of that and have x by itself, we're going to divide both sides by the tangent of 49 degrees. And so let's go to our calculator. We're going to type in, first of all, type in 11, use a division symbol, and then type in tangent 49, and hit enter. Boom. 9.56, so probably 9.6 is what the answer will say. Yep, 9.6. All right, let's do one more. Number 24. Okay, 24, we're trying to find actually the hypotenuse here. We're given the adjacent side. So adjacent over hypotenuse, that's cosine. All right, so that's I believe that's what it said. Yep. Nope, I'm wrong. X is there and 8 is there. No, that's not right. What is it? Yeah, X is the hypotenuse. All right. Okay, so we're going to do cosine of 28 degrees is equal to adjacent over the hypotenuse. Now, similarly to last time, we've got to multiply both sides by x. And those x's canceled out, so you get 8 over here. Now, to get this x by itself, we have to divide both sides by the cosine of 28. That's just a number. And so we'll have x is equal to 8 over cosine 28. And let's see what that is. 8 divided by cosine 28 degrees. And we hit enter. And basically, they may say 9.1. Let's see. Yep, 9.1. Okay, now review this video as often as you need to. Do the rest of these on your own. Show the work, and then upload it for me. All right, y'all have a good day. Bye-bye.